today we are going to see in our lab how we can create our own image. All right. So to do that, first we are going to create an create an container by using some image. So let's take example to create a container. So first I am just checking whether the images are available. So I have a lot of images. So we'll use one of the image to create our container. So we'll use docker run command to create container. We'll use it and the name of container will say con1 is container1 hyphen rm. So this is a new flag we are using in our lab. So what this new flag rm means? Rm means terminate after use. So as long as our work is completed, it will going to terminate the container. All right. So in that case, what will happen? Whatever the changes we have done is going to be no longer available because current container will be get deleted or it will be immediately get terminated. So let's say example, if I run the command apt hyphen get update, so it will update the Ubuntu machine. So update is over. Now let's install another package. Let's example git. So it will install the git package on this Ubuntu system. So here we'll say yes to continue. Now git installation is completed. Let's install one more package, Python. So why we are doing this? Just to test in real case or in real scenario how time consuming process to do the installation, do the configuration and repeat the same task for multiple times. So now here what we are going to do in this case, I mean, we have already used the option rm while creating the container. So definitely once we exit from this container, this all effort, all the time which we have dedicated to install these two packages, it's going to be waste. The reason behind that is all the configuration is not going to be stored anywhere. So solution to this problem is always create an image for a safer side, always commit this container and create an image. So once we have image, we can use that image multiple times and that image will have all the configuration, all the packages, same as what we have in the container. So we have done with the installation. Now we'll do the exit. So as we did the exit, it will immediately terminate that. So we can see that here one container is running, but it's not our ID. Our ID is 7005. All right, so it's not running. Let's check whether it's present in not running mode, that is in exit mode. So it's not present, so it got deleted and our effort also got deleted. So why we did this? So reason or the idea behind this is if container get deleted, then data will be not available. So there is no possibility that your data is available but container is not there. Until and all we create an image. So if we create an image, Definitely, if container also get deleted, not an issue. All the configuration is stored safely, and that we can use to deploy the number of other containers. All right. So now let's again do the same command without rm. So this will going to create a container with the same name, con1, and same machine, Ubuntu operating system with latest stack. All right, so we got an access. So we'll run the same command, apt-get update. So it will take few minutes to get it updated. All right, we successfully updated the Ubuntu. Let's run other command to install git, and same time we'll install Python. So these two packages we are installing. So it will take few minutes to get in this packages installed. All right, so both the packages is installed. We'll check the version to make sure installation completed successfully. So we can see the version of git, that is 2.7, and version of Python. All right, so both the packages is installed. We have done the installation. Now for the testing purpose, so I will create a file touch1, and I will do ls, so I can see that file is created. All right, now we'll do the exit, and in docker ps will not get this container because we have done the exit. Now what means non-persistent? Non-persistence not means that data will be not in the container, it will be. So for let's example, if I do ps-a and grep this id, so it's there, but it's not running because we have just do the exit. Now non-persistent means the data will be not available if container get deleted. So we need to take care of it. It not means that data will be not available inside the same container where we have did our work. So on this container we have just did our work. So if we go on this container, the data will be there. So I do ls, so my file is there. If I do git -version, so git version is showing, that means git is there. Now if I test Python, so Python is also there. So if I reboot the host machine, or if I turn off the Docker and again restart the daemon of the Docker, it will not going to create any problem with this container. But if something happen, or some you accidentally deleted, or you do not require something like that, then all the configuration will not get from other way. It will not going to be saved on the Docker. So that's the reason we were discussed that if you want to save something for persistent, or you want to store store the data or configuration from long, then we have to use the volume. So volume allow us to write the data on the host machine. That means on this machine. On this machine, I can write the data from this container. So if this container get deleted, still I will have the data on the base. So I can spawn the new container or create a new container with the same data I can attach or show on that container. So that is one possibility. But in this session, we are learning to build the image. So what is the role of image now here? So we have an container with the name con1 and with the ID last is 54D7. So we can use this container to create our own image. All right. So what is the advantage of having our own image? So let's see our image. So our image, local images are multiple images, but this container that is 54D7 we have deployed from Ubuntu latest image. So Ubuntu latest will not have the changes. So let's say example something happened and this container is not working or this container is not available. Then we'll have the option to install the OS from this image. That we can do, but will not have the installation of Git and Python and em update. All right. So this is a base image, read-only image, but we have used this image, we have created our container, we have did the customization. Now again we have to bring this container in this form, in the form of image. Why we are bringing it? Because we cannot use the container to create another container. So if you want to save the data for long, if you want to upload that data or that whole application with configuration on the GitHub or on the Docker Hub, we can write down the build command to create an or to build an image. All right. So, but here first we have to do the commit. So commit will create a image for us. So command is pretty simple. Docker commit and then the excuse docker commit and then the container ID. So in our case the container ID is this, and here the interesting thing to give the proper name. So we have to first check our repository name. So my repository login name on the Docker Hub is Ajay CS. So I will use the name Ajay CS. Why I am using it? Just I will explain you after this command. So I will give my name test git python :v1. Now why we use this format? If you want to upload this image on the Docker Hub in future, then we should have the first username before the image. All right. If we do not have the username before image, the Docker Hub will not going to accept this image. It will throw an error. It will not going to accept. So that's the reason we have given the same naming convention. Now the next point is once you created an image, you have to upload that image on the Docker Hub. So to upload the image on the Docker Hub, we have to use docker push command. But before push, we have to make sure we have logged in into our account to upload this image. So we'll say docker login. So it will say the username. So my username is this and my password is I have entered. Now it will say login success. That means you successfully logged in. Now we have to use the docker push to push this local image into the public repository. Now we have to copy this name and also we require v1. Now it's uploading the image on Docker Hub. So few things to note. First, we have created an container from Ubuntu image. After that, we have made the changes into that container and we have created an image from that container. So all the configuration which inside that container is now it's writing into the image and the image name is test underscore git underscore python. Now this image will have all the installation of Git, installation of Python, plus updated Ubuntu. So if anyone require to use this kind of installation, or they need pre-install Git, pre-install Python or something, so they can just type this name while deploying the container. So once our upload is completed, then we'll see how we can use this public image to deploy our local container on this system. All right, so we have successfully uploaded our image on the Docker Hub. So let's check our images, and we'll remove the local image. So for that, we'll use Docker remove, that is RMI for image, and the image name. So sometime we will get error that no such image, because we have to give the version name as well. So it's got deleted. Now we do not have any local images, okay, with the name test underscore git underscore python. Now we'll remove our container also, which we have created by the name con1. So we'll say docker. After that, we'll check all container with the option A, and we'll do grep con1. So here we have that container. So this container, let's example, as of now we not require. So we'll say docker rm remove, and anything we can give the name or ID. So it says it's running, so we need to stop it. So we'll say stop, and now we can remove it. So it's successfully removed. Now if we check in list, it will not there, so no output. That means now this container is not available. Now let's example, we want to do the same type of setup or type of job where we require git and python should be installed. So now we do not need to create a fresh ubuntu machine, update it, and install the packages and all. What we can do is we can run the docker run hyphen exe hyphen it, and let's say example, giving the new con1, and after that, here interesting thing is we have to give the complete name, that is first your login, and after that, login means your username, so username, and after that the name which used to create the repository. So in our case, we can check from here. So we have created test under, so we have to refresh it because it's not showing here. So it should show. So this is our, we have just created it with the name test underscore git underscore python. So test underscore git underscore python. Now first it will search locally. By default it always search locally. Now what happened, it says no pull access because the version we have not included it. So if you run same command again it will not going to work. So we have to give the version name v1. So now what says response demo repository exe not found. So here we are not going to uh, do any execution. So run is okay to go without exec. Now what it says, con1 not found. So hyphen hyphen name we have to say. So in this way we learn the different error. So that will help us to find out when we actually do the hands-on. So the correct command is docker run -it and hyphen hyphen name. Here we have provided. If we missed out this, then it will give the error. So hyphen hyphen name and the new name of that container which we are deploying. And after that, our login username and slash and the correct image name with tag. So this is a complete command. So now it will download that complete image and create a container with the name newcon, and it will give you the interactive shell. So we'll get the access inside that container. So it will take few minutes to get downloaded. So download completed and we got an access inside that container. Now the very first we'll check whether git is there or not. So we'll say version, so it's there. And let's check Python version, so it's also there. So all the configuration installation exit in that image. Now this image anyone can use if they need git and python pre-installed. All right, now if we check docker images, so we'll get the image name here because we have just downloaded it, and the container we can check with the name with the command docker ps -a, and at least we should have the ID or name to search it. So we'll say grep to find out that particular container. So container is there, but we have just exited from that container. So this is how we can create our own image and upload on the Docker Hub and use the same image for multiple purpose without reconfiguring the same thing. Thank you for watching it.